Let's take a look now at the idea of the angle between two planes. First of all, if we think about this for a second, two planes are going to be parallel if and only if the normal vectors for each plane are also parallel. And if you picture that, that should make sense. So let's find the angle between these two planes. Well, the first thing I want to look at is the fact that I'm going to call this n1, this first normal vector, will be 3, 2, negative 1. And the second normal vector, I'm going to call it n2, will be 9, 6, negative 3. And notice here that n2 is actually equal to 3 times n1. Therefore, these two planes are in fact parallel because this second normal vector is just a constant multiple of the first. So they're pointing in the same direction. They're parallel to each other. Now let's find the angle between these two planes. Well, finding the angle between the planes is the same as finding the angle between the normal vectors. So again, I'm going to call it n1, this vector 3, 2, negative 1, and n2, the normal vector for the second plane, 3, negative 2, 4. So what I really need is the angle between these two vectors. And to find that, I'm going to stay with a dot product. We know that n1 dot n2 equals the magnitude of n1 multiplied by the magnitude of n2 times cosine of theta. That implies that obviously cosine of theta must be n1 dot n2 divided by the magnitude of n1 times the magnitude of n2, which in turn indicates that theta must be equal to arc cosine, the inverse cosine, of n1 dot n2 over the magnitude of n1 times the magnitude of n2. And notice obviously that this is in fact a scalar. This is a number. A dot product gives me a number, and obviously I'm dividing it by two magnitudes, which also gives me a number. So let's see here. n1 we said it was 3, 2, 1, a 3, 2, negative 1. So the magnitude of this first normal vector would be the square root of 3 squared plus 2 squared plus negative 1 squared, which is the square root of what, 9, 4, and 1, which gives me root 14. And then the magnitude of n2 will be, square root of 3 squared plus negative 2 squared plus 4 squared, which equals root 29. So now I need to find n1 dot n2, which would be 3, 2, negative 1 dot 3, negative 2, 4, which would be equal to 9 minus 4 minus 4, which is 1. So I know that this angle theta will be inverse cosine of 1 divided by the square root of 14 times 29, which is roughly 1.5211 radians. This is radians, which is also equal to approximately 87.1553 degrees.